Today we are looking at how we can breathe new life into one of the most vital component of steelmaking, the blast furnace. We are moving beyond traditional method into a modern paradigm that integrate high-tech thermal diagnostics with the next generation engineering. By looking at the one of the furnace rebuilt, we can see how right synthesis of data and design can change everything. The layer of defense at the center of the furnace, temperature are extreme. The only thing standing between successful operation and a catastrophic failure is a thin dynamic barrier called protective skull. As we all knowing, this skull protect the health of the hearth wall from the chemical attack like zinc and alkali, as well as the physical threats like thermal stresses. Measuring the skull is the absolute key to making a furnace last for decades rather than a years. And management of this is a typical skill of a operator. Now coming to the contrast of traditional and modern diagnostic, here we can see how do we see inside. For years we really relied on a thermocouples which are supposed to be the heart and which essentially gives thickness based on the heat flux, but they have a major flaw. They ignore how chemical changes affect the material, and this is very important, and our operator should know. Now, enter AE or Acousto Ultrasonic-Echo. This tech uses a mechanical stress pulses to get an instant, non-destructive and highly accurate physical measurement. It doesn't replace the thermocouples, it calibrates them with a real world data. Now, the let us see the transition delay, blind spot. Why does accuracy matter? Because of the transition delay, because of the furnace walls are so massive, it can take hours for a hit spike to reach a sensor. So if a protective skull is lost and then rebuilt itself within a 4-hour window, the traditional sensors might completely miss the event, leaving engineers in a dark about a potential disaster. So, let's talk about the story of the furnace that we have already undertaken in this presentation. Somewhere, I don't want to name the numbers of the furnace and the name of the furnace, which started its journey back in 1978. But by the year 2000, it underwent a around 70.6 million US dollars comprehensive reline. Now, this project was not just a repair, it was a total overhaul that set a new standard for extending campaign life to 15 or 20 years. So the reline process, as you can see, is basically a four-step journey. Modernizing a furnace is a massive surgical operation. It starts with a prep and purge, transitioning to a cook-only burden. Then comes to the blowdown, followed by a salamander tap to drain liquid metal. Finally, we move up to deep excavation using 12 days of continuous oxygen cutting, removing hundreds of tons of hardened material. Do furnace fail? When we opened up the old furnace, which about which we have talked in earlier slide, the autopsy revealed clear issues, severe shelf deformation, and seared anchorage caused by a thermal tension. Interestingly, these were not a operational error. They were failures of fundamental geometry and cooling designs. The old refractory had worn down from 1000 mm to just 500 mm in some spots. So these were the very alarming situation. Now, the conical solution, the fix was a shift from flawed cylinder to a conical solution. Now, by moving to an 81-degree angle, we better support the movement of a material inside. We also replaced outdated exterior water spray with embedded copper cooling plates that make direct contact with the machined graphite refractory, maximizing the heat transfer and more stability to the furnace. The modernized cooling circuit water in this water is the lifeblood of the furnace. The old system was a dirty loop that mixed fresh and recirculated water, compromising efficiency. The modernized circuit routes fresh water exclusively to the hottest zone like TS. We also cut the pipe length by 50%, drastically reducing pressure drop while maintaining a massive 4,000 ton per hour flow. So these were the challenge met by such modifications. Now, top gas control sustainability is a part of modernization. The new system eliminates 450 ton of seawater waste every hour by using dust catchers and washing tanks with the anti-clogging nozzles. We save massive amount of pumping energy and prepare the facility for future gas turbine energy recovery. Now coming to the brain, which is a VAI Expert System, a modern furnace need a brain. We replace obsolete control with a VAI Expert System, a level 2 automation platform minimizing the human intervention. It uses AI-driven pattern recognition to diagnose an anomaly like hanging or slipping of material and then provides automatic therapy, adjusting the fuel and air mix in real time to keep things running very smoothly. Now, the blow in sequence, which is starting the furnace back up, is a delicate dance. It happens in four phases. The first, drying the new refractory with the hot air, and then filling it with the wood and raw materials, followed by ignition, and finally the first metal within just 18 hours of ignition. The metal can reach its target temperature of 1400 degrees centigrade and further normal state. Now the result. Uh, Now recording the efficiency. Did it work right or not? It's absolute or partial. In 2003, despite a global coke shortage, the modernized this furnace hit peak productivity of 5648 tons per day. It achieved a record low fuel rate, proving that structural and automation upgrades create a system that is resilient to external market shocks. Now, coming to the optimization loop, this is not a one time fix, it's a continuous loop. High fidelity diagnostic lead to preventive operations, data driven reliance, reveal physical bottlenecks, and structural modernization enable record productivity. You cannot optimize what you cannot measure. So, the final verdict is to summarize three rules to define the modern furnace. Trust, but verify with the advanced diagnostic. Remember that geometry is a destiny when it comes to infrastructure, and always treat the furnace as a holistic ecosystem. By modernizing the circularity and nervous system of the furnace, we secure a long term return on investment that we made.